Okay, this is a preview of Chapter 9, Correlation and Regression. This is where you like to see if there's some kind of trend going on with your data, a relationship between two variables where X is the independent and Y is the dependent. Maybe X is the number of hours you study for an exam and Y is your grade, right? Your grade depends on how many hours you put in. And to find a linear correlation, we actually use a formula. Okay, so this is the linear correlation coefficient, which measures the strength, how strong of a linear meaning line, relationship between the two variables. And if you calculated this by hand, I wouldn't, but if you did, you could do this in steps, because if you're reading this, this is saying the sum of the X times the Y. So that's multiply each X value by the Y. The sum of the X's, the sum of the Y's. N is the sample size. And then the sum of the X's squared, the sum of the X's, and then square that value. And then the sum of the Y squares and the sum of the Y's and square that value. So if you do all these steps, then you could plug in the actual numbers. I wouldn't do it by hand. I'll show you here in a second. I would use technology. When you get a correlation coefficient, you get a number, right? When you plug all that stuff in, you actually get a number. That number must be between -1 and 1. If it's not, then you did something wrong. All right, and so if I have a -1, that is a perfect, I mean, they are lined right up together, a perfect negative correlation. Now, negative doesn't mean bad. Let's say the x-axis is the number of hours I work out, and the y-axis is my weight. Hey, that's pretty good, right? The more I work out, the more my weight comes down. As you can see, and even this chart shows, the further away you get from -1 or +1, that would be a perfect positive correlation, then you get where there's not really anything going on here, no linear relationship. And the reason we like to know if there's a linear relationship, that moves us to the second part of this lecture, or not lecture, overview, which is linear regression. Okay, so we'll come to that next. Again, as I mentioned, I probably would use Statcrunch just because it's right there in the lab. To find the correlation coefficient R, but if you're a calculator person, you like your calculator, this is a good website that shows you have to turn diagnostic on, and then you can actually set up your calculator to do it for you. So if you know you have a correlation, okay, there's some kind of linear relationship going on, then what you could do is you could put a line through the data, the best fit line. Okay, so what the best fit line does, these circles are your data values. And then the line is just showing how far away they are from the prediction line. So the regression line is what I'm going to use to make a prediction. You've seen an equation of a regression line before. You have. Y equals mx plus b. It's just we use this y hat to mean this is a predicted value once I plug in x. So how do I get m, the slope, b, the y-intercept? As you're going to see, that's something you should use technology as well. So a residual is the difference between the observed y value, right there, and the predicted, which is the blue line. So as you can see, some of these errors are pretty big, where some of them, that's a pretty good prediction right there, right? This is a very big error. But what the regression line does for you, because you might just say, well, I can draw a line, but what technology will do is find the best fit line. Do I rock it up a little bit? Do I bring it down? And so that's why you typically like to use technology. You can go through the same steps above and you will actually get the regression equation. Just realize if you use your calculator, for some reason they use A for the slope, so be sure you know that, and B still for the y-intercept. All right, I hope you enjoy this lesson, because this is actually very useful in the real world, because we use it to look for trends in data and then make predictions of maybe something that could occur in the future.